Imagine the fastest thing you've ever seen. A cheetah sprinting, a jet soaring. These are some of the quickest things on Earth, but they pale in comparison to the ultimate speed limit. Now, imagine something moving at 186,000 miles per second. That's not just fast, it's mind-bogglingly fast. This is the speed of light, the ultimate speed limit in our universe. Light travels so quickly that it can circle the Earth 7.5 times in just 1 second. It's almost impossible to comprehend such speed, but it's a fundamental aspect of our universe. Nothing we know of can travel faster. This isn't just a limitation of our technology, it's a fundamental rule of physics. According to Einstein's theory of relativity, as objects move faster, they require more and more energy to continue accelerating. Lightspeed isn't just about how fast light travels, it's a cosmic speed limit that applies to everything in the universe. Even the fastest particles we can accelerate in our most advanced laboratories can't reach this ultimate speed. It's baked into the very fabric of space and time. This speed limit is a cornerstone of our understanding of the universe. It shapes the way we perceive time and space, and it influences the behavior of everything from the smallest particles to the largest galaxies. Think of it like this. Space and time are intertwined, forming a cosmic fabric we call space-time. This fabric is flexible and it can be stretched and warped by massive objects like stars and black holes. Just like ripples on a pond, gravity distorts this fabric. When a massive object like a star or a planet moves, it creates ripples in space-time. These ripples travel at the speed of light, carrying information about the movement of the object. The speed of light is the speed limit of these ripples, influencing everything from how stars form to how black holes behave. When a star collapses into a black hole, the information about this event travels outward at the speed of light, affecting the surrounding space-time. It's a fundamental constant that governs the cosmos. This speed limit is not just a number, it's a key to understanding the universe. It helps us unlock the mysteries of space and time, guiding our exploration of the cosmos. What if we could break this cosmic speed limit? Imagine a world where the constraints of our current understanding of physics no longer apply. The speed of light, often considered the ultimate speed limit in the universe, would no longer be a barrier. This opens up a realm of possibilities that are as fascinating as they are mind-bending. What if Earth could zoom through space at the speed of light? Picture our planet hurtling through the cosmos at an unimaginable velocity, traversing vast distances in the blink of an eye. The implications of such a scenario are profound and far-reaching. Well, things would get really weird, really fast. The very fabric of reality would begin to twist and contort in ways that defy our everyday experiences. The universe, as we know it, would transform into a surreal landscape of distorted space and time. According to Einstein's theories of relativity, time and space are not absolute but relative. This means that the faster you move, the more pronounced these effects become. Einstein's groundbreaking work has shown us that our intuitive understanding of time and space is just the tip of the iceberg. As we approach the speed of light, time slows down relative to someone standing still. This phenomenon, known as time dilation, means that a journey that seems to take minutes for the traveler could span years for those left behind. It's a concept that challenges our perception of time itself. This isn't just a theory, it's been proven with atomic clocks. Experiments have shown that clocks on fast-moving aircraft or satellites tick more slowly compared to those on the ground. These real-world observations confirm the predictions of relativity and highlight the strange nature of time at high speeds. At light speed, time would essentially stop for us. From the perspective of a photon, the particle of light, time is a meaningless concept. This leads to the mind-boggling idea that at the speed of light, the universe would appear frozen in time. Meanwhile, space itself would warp. The dimensions of space would stretch and compress in response to the immense speeds, creating a bizarre and unfamiliar environment. This warping of space is a direct consequence of the interplay between speed and the structure of the universe. Distances would shrink in the direction of travel, making the universe appear compressed. This effect, known as length contraction, means that the vast expanses of space would seem to contract, bringing distant stars and galaxies closer together. The universe, in essence, would become a much smaller place. That all sounds pretty cool, right? So what's stopping us from hitching a ride on a light-speed spaceship? Well, physics has a few things to say, and they're not very encouraging. First, there's the problem of mass. As an object approaches the speed of light, its mass increases infinitely. This means you'd need an infinite amount of energy to propel even a tiny object like a grain of sand to light speed, and we haven't even gotten to the practicalities of surviving such a journey. Let's say, for a moment, that we could somehow overcome these obstacles. Imagine we have developed technology so advanced that it allows us to propel our entire planet to the speed of light. This would be a monumental achievement, overcoming the immense challenges of energy, propulsion, and the very fabric of space-time itself. But let's suspend disbelief and envision this scenario. What would we see from our Lightspeed Earth? As we hurtle through the cosmos at this unimaginable speed, the view from our planet would be drastically different from anything we've ever experienced. Well, it wouldn't be the dazzling light show you might imagine. Instead of a spectacular array of stars and galaxies, the universe would appear strangely muted and dark. The familiar constellations would vanish, replaced by an eerie, almost empty void. Light from the universe would hit us all at once, creating a blinding white light. This intense light would be the result of all the photons from stars and galaxies ahead of us being compressed into a single, overwhelming burst of energy. Stars and galaxies in front of us would appear blue-shifted, their light waves compressed and shifted towards the blue end of the spectrum. This phenomenon, known as blue shift, occurs because the wavelengths of light are shortened as we move towards the source at such high speeds. Behind us, everything would be red-shifted, stretched, and shifted towards the red end. This is due to the Doppler effect, where the wavelengths of light are elongated as we move away from the source, making them appear redder. It would be a bizarre and disorienting experience, to say the least. The familiar night sky would be replaced by a surreal and distorted view of the universe, challenging our perceptions and understanding of space. The sheer speed would warp our sense of reality, making it difficult to comprehend the true nature of our surroundings. This thought experiment not only highlights the incredible challenges of light-speed travel, but also the profound changes it would bring to our perception of the cosmos. Section 5. Why we can't break the barrier. The reality is, traveling at the speed of light isn't just impractical, it's impossible, at least with our current understanding of physics. The energy requirements alone make it an insurmountable challenge. But just because we can't reach light speed doesn't mean we shouldn't dream about it. These thought experiments, however improbable, push the boundaries of our understanding and inspire us to explore the universe's mysteries. Section 6. The Power of What If. The question of what would happen if Earth moved at light speed might seem like a pointless exercise. After all, we know it's impossible. But that's the beauty of science. It's not afraid to ask what if. These seemingly absurd questions force us to confront the limits of our knowledge and imagine new possibilities. They spark our curiosity and drive us to explore the universe with open minds and a sense of wonder. Section 7. The universe's speedometer. Even though we can't travel at the speed of light, we can still observe its effects. The light we see from distant stars and galaxies has been traveling for millions, even billions of years. By studying this light, we can peer back in time and learn about the early universe. In a way, the speed of light acts as the universe's speedometer, allowing us to measure distances and understand the evolution of the cosmos. Section 8. Keep looking up. So, while a light-speed Earth might remain firmly in the realm of science fiction, it's a thought experiment that reminds us of the incredible power and mystery of the universe. It reminds us to keep asking questions, keep exploring, and never stop being amazed by the cosmos and all its wonders. Keep looking up, keep questioning, and never stop wondering about the universe and our place in it.